Hello everyone and welcome to another Würth Elektronik eiSos webinar. My name is Markus Eberle and I will moderate this webinar today. We are very pleased that you took the time to participate in our webinar. The topic of today's practice-orientated webinar is RF modules design, do's and don'ts. Our speaker today is Loran Völkel, who is working as Global Business Consultant at Würth Elektronik eiSos. He will hold today's webinar and also answer your questions. Before we start the webinar, I would like to point out one thing. You will be muted during the webinar today. This means that you cannot ask us questions via microphone during the webinar. Nevertheless, you have the opportunity to ask us questions during the webinar at any time via the chat function. You will find the chat function in the webinar control panel. Today's webinar will be about 30 minutes long. The chat questions will then be answered in a question-answer session following the webinar. Just a hint from my side to our referent Lorand. Our screen is now still in the freezing mode, so we have to move on. Thank you. So, for the question and answer session following the webinar, there are 10 to 15 minutes in addition scheduled. If we are unable to answer all your questions within this time, we will answer them via email after the webinar. If you still have any other questions left after the webinar, just email us at eisos-webinar@we-online.com. We will try to answer all your questions promptly. At the end of the webinar, you will be asked to participate in a feedback survey. We would be pleased if you take the time to fill out the survey and help us to improve our webinars. You will also receive the link to the presentation as well as to the recording of today's webinar only in the next few weeks. And now I will hand over to our speaker Lorand, and I wish you an exciting webinar.
Hello everybody, my name is Loran Völkel. Welcome to our webinar from my side as well. My function in this company is like a field application engineer, and also I'm product development manager for energy harvesting and also for RF modules. Today I will talk more about RF modules designs, some hints which you should do and some which you should not do. But before we start, I will ask you to ask yourself, when you make a RF design or you use a RF module, did you ever think about, before you start with a schematic and all this qualification, did you ever think about where the module will be mounted in final position? Where will be the construction, how it looks, the device himself, and which influence you have about that, how much you can tell your colleagues who make the construction that they should not do a metal box and put your module inside without antenna? Or do you have a power that you design by yourself? The power supply is your own design, or you have a power supply which it's from the shelf, you buy from outside from somebody, or another colleague make your power supply? And how good is your collaboration with him? How much you can tell him, hey, I need here a minimum ripple voltage for my module, because else I will not be able to have any transmission. And just in case, if you want to make your own antenna, like a PCB antenna or just a piece of wire, do you have the equipment to match this antenna? Do you have the possibility to make a good matching, to have a good transmission? All these questions are very important on very early stage in your RF design. For the agenda, I will think about some words about the data, amount of data to be transferred, about some comparison about the different interfaces, which frequency you should use, how important is to use external, or when you say internal antenna also enough. Another point is of can you coordinate the material of the housing? Can you influence your colleague to don't use a wet wood case or something which is not so good for RF transmission if you use an internal antenna? how to filter a power supply, which possibility you have to improve the power supply just in case it's not your own design and you must do something because else your module will not working or RF stage will not working so good. Why you should avoid the ground layer under the chip antenna or under the PCB antenna. Um, some position of the devices, why is so crucial sometimes to have a long range or better transmission. First of all, if you talk about amount of data which you have to transfer, I hope you will be not need to transfer 8K video signal in full resolution 12-bit and 60 frames, because then you need something like 90 gigabit per second, and that's to be realized with a easy on the shelf module is not so trivial, honestly. It's a big difference if you transmit a HD video, which is already possible by a 2 megabit, or you just have a on-off button, which you have to transmit just 2 stages, or just a simple sensor, which can be just few kilobytes. If it's a temperature sensor or something like a pressure sensor, you don't need gigabits for that to be transferred. If you compare the different I3 SPI or UART protocols, you will see that every of those have advantage and disadvantage. I will start with the number of wires needed. So like UART and IC2, it's enough to have 2 wires. By SPI, you read already 4 wires. Of course, also the cost is very important. If you use SPI, maybe it's a little bit more higher cost. If you use a UART, it's average, a medium. IC2, it's mostly the lowest cost. Additional, you have to think about if you make the RED testing for radio equipped device, it will be making also immunity tests for the EMC. It's also contain not only just radiation, it's also contain immunity tests. And by the immunity, you will find out that SPI protocol, you have to take care about the tracks and how to make them not so sensible for um, immunity, because UART and IC2 is not so sensible for immunity. They are much more robust. Then again, if you have a data verification, if you need a acknowledgement bit, yes or no, it depends on the protocol which you will decide to be used. Additional, you can choose between different standard radio protocols. Today, you can also start to do something if you want to have a 5G communication by mobile. But I don't know if you want to put your alarm system on the 5G. Maybe if you want to transmit also the full HD 360-degree camera from each room, maybe then you will need a 5G connection. LTE is also with a HD possible. Or you just need a very, very low power beacon, like you can make that by the BLE. Very simple usage, maybe without having access to grid, or not need to put a battery, an indoor solar cell, or thermoelectric generator or TEG will be enough to supply the energy for a small BLE, which can be received by any mobile phone or tablet, whatever. You have a possibility, of course, to do by Wi-Fi with Wi-Fi module. There are also different standards in Wi-Fi. The most popular one is this 2.4 gigahertz, which can be easier used and not so big trouble like the 5G version. But definitely when you're talking about security and you want to be safe and secure, you may have to choose maybe a proprietary radio, because you will be not be so easy to be jammed, you will not be so easy to be hacked and so on. Finally, if it's something very important and professional use, you will decide for a proprietary radio. For the frequencies in ISM band, I will say that industrial frequencies in Europe, it's very often used 433 megahertz, 868, and less 2.4 gigahertz. The point is that 2.4 gigahertz, it is quite difficult because, well, you can buy the module is not a big issue, but to be able to communicate in an environment like I can tell you for myself, in my home, I'm not living in a big city. It's a small countryside city. It's not a village, it's a city. But if I start my spectrum analyzer and set up the 2.4 gigahertz, I can see so much allocated channel frequencies from Wi-Fi, Bluetooth, Zigbee, all the other drone remote controllers and everything that actually is quite impossible to communicate in this area according to the limits of the power and so on. So today I will definitely go by 868 or 433. Of course, in US, you need, instead of 863, you need 915 or 304, 515 megahertz. So every country have a little bit different frequencies for this communication. But the most important is thing, it is to have a band where you don't need to pay a license. And in case like you're making a professional microphones or so on, then you will need to go in another frequency where you can uh, yeah, actually you buy the rights to use this frequency in a dedicated area or a dedicated application, and that's more secure, and you will be not so allocated in bands. Then the next decision is which kind of antenna you want to use for your RF module. You can decide between a chip antenna, which is already easy to match. You can match it on a PCB once, and there is perfect matched and very good. But of course, it's not so effective like if you make a PCB antenna. Of course, also the costs, but the space, if you have the space, I will go with a PCB antenna. If you don't have space, you need a chip antenna. If you go for frequency where you can use a wire, it's also a very cheap version. The cheapest one, you put just a wire to the PCB, directly solder it and leave it inside the box. Maybe it's not so nice when you're moving the box because it makes some noise. Or you can do also a dipole antenna on your PCB, or there are some different application. Depends on your frequency where you can use this kind of different antenna types. Additional, you can decide if you want to use external or internal antenna. In case you have a aluminum box, you have no choice. The internal antenna will be not able to make a transmission, so you have to decide for external antenna. And in this case, the best thing, you have SMR connector, and you put somehow this construction that your SMR connector is looking outside of the box directly on the PCB, so don't have any additional wire between the modules and the antenna output, because you don't want to have too much losses. And effectivity, the range and the better connection, it's always having a small external antenna. That's the best thing what you can do. It doesn't look always nice, but it depends on the device. If it's a Bluetooth dongle with an external antenna, is maybe not the best solution, but if it's a machinery, external antenna can be accepted. And it's always a good way to design that way, because then you are safe from the metal shielding of the machinery or so on. Additionally, you have to think about where your device have to be operated, because it's a free field outside somewhere, or it is in a building where you have some, sorry for the German words here, like the first one, holds means wood, then plastic, then glass, then this is concrete, this is beton with metal, this is a metal wall itself. Sorry for, I forget to translate this picture here. Well, it depends on the material to where you use this module, because you can have a strong shielding if you have a beton with steel. The transmission to a beton wall is not the best. I had some bad experience when I make my own Wi-Fi at my home, and I find out that to put my router in the cellar in the basement, it was not the best thing to reach my second floor. So without a repeater, was not able not to have Wi-Fi signal. So I have to reconsider everything. And yeah, Beton is not the best conductor for RF. It's a good shielding in this case, but not the best way. One of our customer, he has a nice application. He have to track his device, which have been shipped in a metal container and a ship, and he want to have a connection to outside. You can imagine when the metal box completely best Faraday cage shielded, and he want to have a transmission to outside. He was not able that for every each device that he want to track, he go with a drilling machine and drill a hole in the metal wall of the container to have a external antenna outside to be able to track his device. So that's not so trivial and not so easy to do. You have to think about even in the free zone that you have this Fresnel zone where you have to carry on where are you placing your device if you want to have a good range. If you put on the ground, you may have not so the same distance like if you put on top of the building, or if you have a high building and you can do much higher range, especially when you don't have any obstacles or mountains between. With the same power, you can reach much higher range just placing the device in the right place. The transmission range, of course, also depends on the antenna type, which kind of gain you can achieve, or about the sensibility of the modules, of course, of the transmission power. But sometimes the transmission power, it is limited by the law, by the rules. So 0 dBm is 1 milliwatt. The maximum what you can use normally in industrial environment is this limit of 500 milliwatt. So it's 27 dBm, which you can reach in a free field. If you have an output of your module by 70 dBm and you have a gain of 10 dBm from the antenna, you have the 27 dBm. So that's the limit of 500 milliwatt. So you have to think about this maximum power. And if you want to improve it, it's a kind of easy thumb rule. 6 dB improvement, it's a double range. But if you double the frequency, you will have the half range. It's also a easy rule to correspond to the, if you want to achieve a big range, you should not think about doubling the frequency. And if you increase the power by 3 dB plus, it will be doubling the power, of course. And if you increase by 10 dB, you will 10 times increase the power in this case. Additional, you have by the factor of the transmission range, if it's the environment, how it is the environment, which kind of reflection do I have, which kind of coding do I'm using, do I have radio interferences, some different collision, blocking, jamming, whatever, you're close to a radio base station or mobile phone base station and you're close to an airport. It's always a difference where I'm placing my device, what is in the environment where I want to operate my radio modules. Additional, you have to think about when you're planning and you're designing about the power supply. If the power supply have a small ripple, the rest ripple, it should be not bigger, like I would say 20 millivolt delta. It's quite more like enough money. Many of modules doesn't like, then they will be happy if they see just a 5 millivolt or maximum 10 millivolt ripple. And you can improve this in case that you're putting some capacity and output of this power supply. You can put different multi-layers in parallel, and you can reach a better ripple filtering. You can try to put some ceramic capacitors. This is the easiest way when you're trying to filtering this voltage delta ripple, or you can try to put a LC filter. In my previous job, when I was designing remote controls, I was always placing on my output of the power supply a kind of LC filter. At the beginning, it was a 0 ohm resistance instead of the L, and I keep the pad free for the capacity, just in case when I go to the EMC lab and I have to make an EMC test and I saw, oh my God, there's too much ripple on this voltage. I have to improve somehow. So I have the pad for the capacity. I had my box with some capacitors and my ferrites, chip-bit ferrites or inductors board, which is fit. And then I was able to place this additional LC, or sometimes if you have space, you can put even a P filter. That's much more reliable, and you have a better effect if you have a possibility. Before you make a redesign, it's anyway helpful. If you put, instead of polymer capacity, you put this ceramic capacity with the same value, you can see already you can decrease this peak to peak down to 10 millivolts. And if you split even that in many different capacitor, not only just one, you may have cut and um, make it lower the ASL and ASR value, and because you put parallel in a capacitor in parallel, and then you will even be able to decrease the delta ripple very fast. Here's an example how to do this on output of a power supply, or you can do that on the input of your VCC of your RF module. If you know exactly the value of the switching frequency of your power supply, if you know the ripple which you want to admit maximum, and the ASR value, and also the ripple voltage of above the storage inductance, you can calculate the output capacity quite easier. And we have some also application note for how to design a good power supply. If you watch on our website, some app notes on the power supply, how to do a very clean output voltage. Normally a buck converter, it's more filtered on input, and a boost converter needs more to pay attention on output, because the boost converter is more dangerous on output according to the ripple. And if you have a buck boost because you have a battery like a operation, yeah, good luck. You have to fill the input and output. That's the way, that's physics, and this is how it works. But it is always a way possible to decrease this ripple voltage and to make it smooth as possible, that your RF module do what you have to do and have a clean voltage. If you get that kind of ripple, like 400 millivolts on the output of the power supply, maybe some a low-cost power supply, or somebody who doesn't care too much because all other devices working quite properly, this is the not best solution. The only one thing what you can do here, to put additional filter and change the capacity. Maybe you have the possibility to change these aluminum capacitors to the polymers, or the same footprint. Maybe you are able to put a ceramic capacitor which will have low ASL, low ASR value, or to add additional some filtering. It's very important on the economical point of view when you start to design RF modules. You can decide to make your own completely RF module by yourself. You buy the chip, you buy the passive components. This is in costs quite very effective. It's quite low cost. You're maybe copying and make a copy paste of the reference design. You make your first prototype, but then you have to go to the final R&D qualification to be qualified, and then the troubles start, because then you will find out, oh my God, this is not working like expected. I have to redesign this. I have to do this. I would suggest by today, you should focus on your main work. You should focus on your device, not designing the RF module by yourself. Let them do it for somebody who have more experience, more long years experience in that, and buy a little bit more maybe expensive, or like the passive components and the active components piece by piece. But this cost, when you buy a module already, a pre-certified qualified module, it's much faster, the prototyping, first of all, and second, if you go to the final R&D qualification, you don't have all these troubles, because the module have been already tested. He did already fulfill all the requirement. Doesn't matter if it's that for US and you have the FCC rules, then as if it's a VCCI for Japan, or this is a CE or for Europe, you already have everything done. And you can save a lot of cost, like if you have a Bluetooth module and you think, oh, Bluetooth is easy to use it. When you sell that and you declare that as a Bluetooth device, you have to pay for the qualification just roughly 20,000 euro to reach. And this money can be saved in that case that if you buy the pre-qualified Bluetooth module with everything already done and the certificate, you just need the last entry to list your company on the Bluetooth listing, and that's not so expensive, and you don't need to make all the tests because the EMC lab or the laboratory will know exactly what to do. And if you have the certified and you have the ID number, everything is already done. So it's easy going and time saving and a special, yeah, less trouble, definitely less trouble. What you should not do, this is something which I want to pay attention, especially by the ground layer, especially when you use a module with an integrated antenna and you have a PCB with a full completely ground, and you solder this PCB on your with an integrated antenna on your main board. um, the ground layer under the antenna will make detuning and make almost no transmission possible. The best thing is, if you use a module, look into the application note and make a space where this module will be placed and solder it, and keep ground plane free. The best thing is put it somewhere in the corner. If you put somewhere on the corner on the PCB, you can skip there the ground layer in this area under the antenna, underneath antenna, no ground need and no tracks. It's not allowed to have any tracks because you can recouple this signal into the tracks, and you make a own EMC problem maybe, or you may have immunity problem, whatever. But avoid tracks around beside the antenna and the ground. Grounding is one of the most difficult area where people start to think, oh my God, what I have done. This is an example from the consulting software company, Dr. Mulhouse. And you can see here, if you take the module himself alone by the PCB antenna, and you have these characteristics of the emission, and if you place that to a main board where is a full ground plane and you have ground plane under the antenna, your transmission will be, I would say, not too many meters in this case. You may have not a good transmission. As soon you move that outside of the ground layer, you have a much better transmission. The best thing what you can do to place here, but keep under the antenna on the main board, keep this space free of ground layer. Under the antenna directly, keep this space free from ground, and then you have a quite good transmission. Of course, if you can tune exactly the position according to the ground layer here on the middle of the board, it's also a good transmission, but it's quite difficult in the construction to realize that. So in my opinion, to put on the corner of the PCB somewhere and keep ground plane free this zone is much better. When you're using a housing and you have like a wood material box, or you may have a plastic which is very, very moisture sensitive, or somebody from marketing, I had this experience, had a good idea. The box was not looking so nice, and they say, "Hey, let's painting in a nice color," and they use a very, very big number of layer of painting of metallized color with lot of nice metal plate inside. And finally, we find out after painting the device, it was not able to communicate because the internal antenna was reflected inside, that there was no range possible. So the last thing was take a drilling machine, drill a hole on the side and put external antenna. That was how to meet the design, nice looking, and the function together. So especially when you design on a plastic box, and the marketing department decide, oh, plastic is not so nice, let me put it in a steel box because it looks much better and making more heavier and more nice looking, and then you have the internal antenna. So good luck for the transmission. Maybe you should put a drum like in the jungle, and that will be also working better. But for RF, you need the external antenna definitely if you have a metal box. That's one of the point where you always be in contact with the colleagues from the construction department, and sometimes even it's nice to have the marketing department together to have a final decision how the books is looking, what material is used, and then decide is possible to use external or internal antenna. Also, the position of the RF module is very important where to be placed, because if you put that on the earth, directly on the earth, well, one of the customers says in one application, he tried to aim the frequency where he can generate some skin effect on the earth, that he has a transmission only on the earth, directly zero ground line, and finally he did give up and put his device a little bit more in a higher area, because just few meters, if you want to increase the range, you can extend from few meter to several kilometers just placing the device in the right place. um, that's something which you have to think about. Where is my RF module placed, or where is my antenna placed? If the RF module is not possible to place it somewhere on a higher place, but at least the antenna should be on the highest position and not directly on the earth. By the way, you can try this experience by yourself. Put your mobile phone on the earth and take your Bluetooth headset and look at how much will be the range with the mobile phone on your desk or on the earth directly. So this is a nice challenge to try out what is the best position of the RF modules. Some added value. Finally, when you finish your product and you finalize it something, it may be a question that you need a security and how to make a good secure module. We can offer from Würth Elektronik vProWare. This is a special encryption, proprietary encryption, and we can make the firmware for you tailor it as you wish, as you are to know your needs, and you can have a very secure encryption. Of course, the interoperability using a proprietary system is not so given like if you use a standard Bluetooth or Wi-Fi, but you have more security, you have no jamming problem, you have no problem for uh, somebody listening your system or breaking through your system. A proprietary solution is always welcome, and then we can offer this vProWare additional on top on your stack, on your radio stack. Just talk to our sales guy on the field and they will show you all these different advantages. If you use a proprietary system or even if you use a Bluetooth stack, you have possibility to have a Würth Elektronik special iSmart profile on it, and you can have some safety additional. And communication is still very simple, just with using some IIAT's commands. Like I told you, we can offer technical support worldwide with our local FIEs. All our sales guys are also engineers, electronic engineers, and they can not just make an offer in terms of how much cost this module, they can tell you also how to do it, how to not do it, how to handle this module in the design. They can also support you in design directly. We have more like 20 years experience because Würth Elektronik did both the company Wireless Amber, and Wireless Amber have a long term in RF communication experience. In this case, frequencies from 169 megahertz up to 2.4 gigahertz, and some new products which we have also in sensors and GNSS. You can try out using these evaluation kits from us. We have this Amber Pi, which have already these different temperature sensors, acceleration sensor, um, moisture sensor, and you can connect to the Raspberry Pi and you can do your small automation or just evaluate how it could be work all that together. Each module have a small evaluation development board. Um, and you get this, you can get also with a Bluetooth dongle addition or with a proprietary dongle if you use a different communication standard, and you can try out how that works. And the software to test it is also free of our website. You can download it for free of charge, and please ask our sales guys for a demonstration. More information you can get in these books. how to make a good power supply, like in theology of magnetics, how to make a wireless power transfer, or some different books about capacitors and also about modules like magic modules, power modules. We say magic module because it's very small and tiny and very effective. So that's the magic. So now we have some time for questions. I will look into the questionnaire. If you place any questions, please feel and type your question in this chat question window, and it will be listed on my desk, and then I can try to answer it.
Yeah, so thank you, Loran, for your interesting presentation. As you have mentioned, now we would like to turn our attention to your questions, and we wait a little until some questions come in. And I see the first question, Laurent. Are your modules certified?
Yes, all our modules are pre-certified. Depends, of course, for which country, which frequency did you choose. Like if you choose the US frequencies, they are FCC certified. The European standards, of course, if you use a frequency module like 868 or 433, they have also the CE and the certification, everything already done. So even if you buy a Bluetooth module, we have a Bluetooth certification already. The last thing what you have to do is just to be listed on the Bluetooth listing, and that's not the big amount like when you are making your own Bluetooth module.
Okay, so thank you for your explanation. Then as we have a look at the next questions, just a hint from my side, you will receive the link to the presentation as well as to the recording of today's webinar only in the next few weeks. We will send you an email. Okay.
So I see another question here.
Yeah.
If a switching regulator at 2 megahertz is generating noise at 200 megahertz out to output, how do I filter it on the output with LC or P filter? How is the formula, etc., to determine the correct value of inductor, beat, and capacitor? Okay, you have a 2 megahertz switching generator, or so. Okay, it's a switching power supply. 2 megahertz is quite usual today. And of course, you have there some harmonics, third, fifth, seventh harmonics. And the best thing in this case to use, in my opinion, to use a P filter. And how to calculate the P filter, you can see that in the theology of magnetics. I will start for 200 megahertz. For a first step, for a first test, I have some experience in EMI, and I will say I will do a P filter with a 1 nanofarad capacity and 10 nanofarad capacity, maximum up to, I would say, 22 nanofarad, low ASL, low ASR ceramic capacity, and I will place a ferrite bead for something a value by 120 to 150 ohm impedance, and that will be quite enough for this 200 megahertz. As more bandwidth you can get, as more better is. Of course, if you want to have exactly only just a 200 megahertz, you can do it. But the easiest way, what I would suggest in this case, use the LT Spice, which is on analog device, because they both linear technology. You can download LT Spice, and we have the whole library for the capacitors and the ferrite beads for the LT Spice. And if you simulate that in a system, like a 50 ohm system impedance, that you have a correct matching, you can see exactly the working of this filtering. And I will put that then in the output of the regulator or the input of the RF modules. That's the easier way in this case.
Okay.
I say from another question from a good old friend, just say hello to him. I find a self-generated EMI can easily couple to the antenna or wireless module. Which techniques can be used to suppress this EMI? I guess this question can be answered from your the best because you're my EMI guru in this case. Um, and yes, the antenna coupling the antenna with the wireless module, it can very often make this coupling, and that's the very important where you place the module himself, where I can put my antenna and where I put my um, modules on the PCB, the exactly position. And the best technique to decouple that, if it's an external antenna, it is to using a Faraday cage, so using a metal box. If it's an internal antenna, so on the PCB himself, so on the module, if you have the antenna on the module, again, it's the corner. If you have a good PCB from grounding, keep one corner ground plane free and place the module in that place. And this is the best thing what you can do to not generate EMI from the own wireless module into the system. Else you must screen it, you must somehow do it because you're emitting something, and this emission will be catch from every PCB tracks, because 1 millimeter PCB track is 1 nanohenry inductance, and according to the frequency you can use, it will be an ideal antenna to recouple in. Well, more questions coming in. Let me see. Okay.
Yeah, the next question is, Laurent, how likely is the introduction of noise from the base transmission frequency into the power or data lines of the underlying system, especially via wire-bound transmission back from the power or data input of the module?
I have to read myself additional. How likely is the
Yeah, yeah.
introduction of noise from the base transmission frequency into the power of data lines of the underlying system, especially via wire-bound transmission back from the power of data input of the module? Okay, I understand. So you have a module, and you're afraid that you will have a transmission back from the module into the power system. This is the reason why I say I always like to have a decoupling LC or P on the VCC input of the module to not generate, if the module makes some generation of the conducted, I would say conducted emission on the power supply, to avoid and to cut them away, to filter that. Normally, I would say our modules are in that way designed and made that you will not have a noise generated from the RF module inside to the system, but it could couple like before. Candid ask, how can be that it recouple your own transmission into the lines of the rest of the PCB? So the best thing is, don't put any sensitive areas, don't put any sensitive tracks close to the RF module, and the UART or IC square or SPI connection, it won't be that much affected, only if you make a lot of dirty works on your PCB tracking. So because of that reason, I will not suggest to push the auto routing button. Track your own routing, and if you have a good ground plane concept, and if you put the ground layer under antenna free, but under the module himself, you keep the ground plane and you use the ground connection together, and you have a low impedance, normally you will not contaminate the ground and you will not contaminate the rest of the um, connection of the as IC square or UART or SPI. So that will be not an issue for you. And in case um, you are thinking that you will have a back connection into the system by the VCC, I would suggest please filter it, because this is the best way.
Okay, so thank you, Laurent, for your explanation. And now, if there are still any questions left now, you can also just email us at our email address isos-webinar@we-online.com. So thank you very much for your attention, and I hope you enjoyed our webinar. Also, many thanks to you, Laurent, for your great webinar.
I have still one message to you. Please think about that on the RF module or EMI design. It's always existing a solution. Don't give up. Never give up. There's always possible something to do it. The thing is, maybe you don't see it. And because of this reason, I recommend try to get in touch with us, try to contact us, our salespeople, our FIEs, because maybe we will look to your board from a different point of view, different angle, and we will see something which you may not in mind because you are too focused in your design, you are too overloaded with the information, with the qualification, everything, and another electronic guy, it will look to your PCB and will ask you, hey guy, why you do this? Why you don't turn this in that direction? And then you can see that works much easier, but maybe sometimes you need somebody from outside who's not so in charge with all the function. This is the message which I always tell people, don't hide, talk to each other, and then you will find a solution. There's always a solution there. And doesn't matter where you are located worldwide, we are offering with our salespeople locally FIA support, and we're just not selling the components or the modules. We support you in the design and give you some interest advice how to use it. We are supporting you in firmware development. If you don't have the manpower to make your own software firmware, we offer also this firmware solution to you, and please use it. It's for you. It's for free, and try it and ask us. We can do our best for you. If you want to be in touch with me, we have also a Twitter channel. We have also this online small tutorial channel. If you want to be in touch with me, I have also a LinkedIn account. And please, maybe we can meet somewhere in some exhibition or congress. I will be happy if we can discuss about some RF or EMI. Thank you so much for your attention. Hope see you soon.
Also from my side, thank you very much. I hope you will hear us at our next webinar, and I wish you a good day. Goodbye.